and all the way through on it. And it's just kind of the story of my life, I think, was with the Apollo.
And the shuttle.
Well, and as my daughter says, and the shuttle program, yes, it is. It's just a lot of years.
Okay, excellent. So Bruce, Mr. Brandt, did you share with us about you? Oh, and maybe Bruce is.
I guess I'm really not very much prepared for
Well,
this.
I can tell you about Bruce.
Didn't know what was going to happen. Didn't know what was going to happen. It's
No.
okay.
Cool.
I can tell you about Bruce. Bruce,
Yeah, go ahead.
Bruce and I worked together for many years. He was in mechanical systems, early Apollo, and he worked through all that. He went to Seal Beach. He came back to Downey. He did docking on, after Apollo, he did docking for the shuttle. He's worked many programs at Seal Beach. He and I worked together, and he became chief engineer of Teal Ruby.
That's amazing. Fantastic. Yeah, thanks, Chuck. Thanks, Bruce. So Ed, could you share something with?
Yeah, those are great memories, Chuck.
Yeah.
Excellent. So Mr. Smith, can you share something with us?
I was kind of a late comer on Apollo. I became chief engineer after the fire and went on to become chief engineer on orbiter and program manager. That's about it.
Well, except a little detail, he was also program manager and vice president on the B2 at Northrop Grumman later.
Amazing. Yeah, thank you so much. Yeah. So Ben, can you say something to everyone?
Yes, I'm really a latecomer. I was working a little bit on the test equipment specifications for shuttle, but mainly the last 20 years was helping test the GPS program, GPS satellite, all the frequency standards, or they call them clocks. And once we did them all, they sent me to Colorado Springs to help the Air Force to maintain and solve any problems with the GPS. So it was very nice babysitting a satellite that we made. That was a very comfortable program to start my retirement. So I retired up there in '98, and that's been 22 years since I retired. So the GPS program, all our Block 1s and Block 2As are finished. But there were some 2As that were still working. They were like 18 years old. If we would have had some good lawyers to give us positive incentives instead of just negative incentives, it would have been much better. But we had a good time. And I still have a house in Colorado Springs and snowbird back down here to La Palma next to Seal Beach, where I worked for 35 years.
Yeah, engineers really should get residuals, you know?
That's right. Some sort of compensation.
See Sergio on there.
Yeah, good morning. Yeah, I actually didn't work Apollo. I was too young for that. I started shuttle in 1973 after college. And I worked all my career in the aerodynamics department and became the senior manager for the aerosciences department for shuttle. Worked a little bit of X-37. And then after retiring in 2006, using the 85 points from Rockwell, I did some consulting for NASA and Langley and Houston, and also for USA.
Hey, let me ask for one thing. Is anybody object to recording of this session?
No,
Go
No.
ahead.
No, I don't. You're
No.
okay.
Yep, it's okay with me.
Let's speak up and be sure that that's the case. Ken, have you started a recording, or can you start a recording?
Yeah, starting. Thank you. Yeah, it's starting. Yes.
Okay. And I'm ready to share my screen now. Looks like I'm talking to myself, and I hope you're not getting a terrible echo.
Now, why don't you tilt your screen just a little bit down and we can see you?
Gary, you need to move your camera a little bit. Yeah, that's better.
Oh, okay. Yeah, I see myself looking sideways right now. Let me do a quick test on the share the screen. And then I will, well, I think I'll just give Chuck the reins at that point, and we can go through his presentation, which is about a half hour. I said I would start that 11:15. I'm a tad bit late, but oh well. We've been known for that amongst the engineerings. So can you bring me up there? Okay, I don't have the other camera working yet.
Oh, I'll send you a request. Didn't see.
I'm
No, your video is on the other computer, but somehow your screen is black. Maybe something is blocking it, or it's not connected properly. But it's on.
No, it's coming live.
Oh, okay. Can see your face.
Yep. Not very well. but-
Everybody has their hat on, just about everybody.
Do you want your hat? I know where it is.
I do.
All the NAA hats, aren't they?
No.
Oh, this computer is the one has the direction. The speaker, the microphone has a direction preference. You have to speak in certain direction, like your antenna. You have to aim it properly.
Usually that one does pretty well. So
Yeah.
I'm gonna silence this one if I can figure out how to do that. There's a function key volume.
Lower left. Yeah, you just mute. Oh, you're not. You mean microphone, right?
Yeah, no,
Speaker.
speaker.
You just lower the volume of your computer speaker.
Yeah, I'm trying a different technique.
Yeah.
There we go. Got it.
Yeah.
Now can you still hear me?
Yes.
Because I can hear myself. I hope I don't have a terrible echo. Okay, so let's go ahead and share my other screen. Share this screen. Okay. We ready for that? Ken? Yep.
Yeah, go ahead. Yes.
We need
ready.
a step change in human evolution.
What do I need to do?
Exactly, Jerry. You're right.
Escape out of there and go back to the Zoom instance, which I don't know where it is.
Oh.
Somehow I'm on the AIAA Shaping the Future.
Oh, that's the browser. If you shrink your browser.
There we go.
Yeah.
Got it. I don't quite know why that's the case, but here we go.
Mm-hmm.
Now, if we go to the share the screen. Do we have that?
No, I haven't seen
No.
your slides. It's a green button, but you have to open your slide first. And click green button and select the screen, with your slides.
Okay, I guess I need to be off of full screen here.
Yeah, you need to open your file first.
I did.
Okay, then you click the green button, share screen, And then you should see a window of several screens you can
I
select.
do not see, oh, I have to relaunch the meeting.
No, 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 you don't have to.
I don't see a green button.
Oh, yeah, that's because you have to move mouse downwards. Move your mouse downward because it's hidden. If you don't move your mouse over, you don't see it.
Oop. I do not have full screen now.
Okay, if you move your mouse downward, you should see a menu at the bottom.
It's you. Or I'm down.
No, it was Cindy from the Meridian.
I might have too many functions going on here at the same time.
That was the.
Try to shrink the other jobs, the other windows.
That's one that you said.
That's where what I'm up to right now. Oh, there's another Zoom meeting instance. Oh, there we are.
Okay.
Share screen. Gotcha. You got a bunch of hacking stuff in there.
Yeah, then pick the one for your slide.
Okay. Oh, pick a window I want to share.
Charlie, I'd be interested in knowing
There we are.
folks that were on earlier programs like the X10, Navajo, G26, G38, and so forth. I started out on the X10.
X10. Interesting. Actually, the other day I was happened to see a video. It's about the moon landing, and in which it cited a rare video clip from Neil Armstrong, and he was talking about X-14. It's like a vertical landing takeoff aircraft.
Oh, was that a propeller aircraft?
Yeah, something like that.
Cool. That was that was one I just saw in the Popular Science or whatever.
Yeah, I think Neil Armstrong was also trained on that one, on that.
Oh my, why don't I get that?
Did you see the share screen? Oh yeah, you did it, but still it's not showing up yet.
Huh. Nope.
No, we'll still see your face.
Okay, so I have to go
So
back
you click
to
the share
partial.
screen, right? And then select the screen you want to share.
Close. We get to close a bunch of stuff first.
We need a step change in human evolution.
We do.
I think it'll take a couple
There we want to
generations.
go. There I am. Yeah, there we go. Share.
Great, it's showing up now.
Now, continuing my step change in evolution, I need to find full screen
That's a
again.
great picture.
Full screen, either at lower. Oh, you don't see it there.
Lower where?
At lower end, lower bottom, you should see a bar, a red bar.
Oh,
And there should be a full screen icon. Yeah, that one.
There we go. Yay.
Cool.
Go back to chart 1.
That's the, oh my gosh, I'm at chart 12. There we go. Yay.
Okay, can I start?
Yes.
I'd like to, I will be less than 30 minutes, but not a whole lot. I wanted to start back at May the 5th, 1961, when Alan Shepard flew the first Mercury flight, suborbital, 15 minutes and 22 seconds. He became the first American in space. 3 days later, he was in the White House getting decorated highly. He was the most popular man in America at that time. 20 days after his flight, John F. Kennedy announced, we're going to the moon. We're going to have an Apollo program. 10 years later, from that first flight, he was commanding Apollo 14. And we'll be talking about that today. I want to talk about the mission and the crew and the hardware and the failures that we had and what we did about them and what made it a successful mission. It was a very important mission because it just came after Apollo 13. We had to prove to the world that we could recover from a disastrous mission like Apollo 13. It was a success in many ways, but we did not land on the moon and we almost lost a crew. So some called Apollo 14 the mission that saved America's moon program. And I suppose it was. If Apollo 14 had not been successful on the tail end of Apollo 13, it would have been bad for us. So Apollo 14 did save the program. It saved my career. It saved the career of a lot of people on this Zoom. So it's pretty important to us. In addition to being to springing back from the Apollo 13 flight and having success, it was about the crew and the determination of the crew led by Alan Shepard. I'll introduce you to him in a minute. I see the Apollo 14 mission as also being one where we demonstrated an ability to recover from some very show-stopping failures. Most people didn't know we had all these failures on Apollo 14, but we did. And decisions were made. And there was much risk in the decisions that were made. And we learned something about making decisions that are hard to make in order to carry out a successful mission. Next chart, please. We've all seen the pictures, and of course we know all these historical events, landing on the moon, returning safely. We did it pretty much on schedule. We did it very much on budget. And we had to acknowledge, of course, through all of that, that the USSR, the Soviet Union, was way ahead of us in many ways. They were the first satellite in space. They were the first animal, the first man, the first woman in space, the first EVA, the first moon probe, the first EVA. Although we like to think that Apollo was about adventure and exploration, it was really about space supremacy, getting ahead of the Russians. We had to catch up with the Russians for political, for world reasons. And so we set out to do that with John F. Kennedy's announcement of the Apollo program. Next chart, please. So the question is, well, how do you do that? How do you catch up with the Russians? How do you win a space race? And here's a picture of how we chose to do that. On the right-hand side is the S5 booster. We all know about it. The lower part of the picture, the big booster with a 7.5 million pounds thrust, it fires off the pad. We drop it away. Then the Saturn II, which North American made, we go through that burn and we drop that away. And during all that time, we get rid of the launch escape tower, which is up on the tippy top. So then look over to the left-hand side. That's what we have left, minus that launch escape system up at the top. That's the assembly that goes toward the moon. So you can see then just below that launch escape system, which is gone, command module, then the service module. Below that is the service module, service limb adapter, the SLA, which has tucked inside of it the lunar module, the limb. Below that, the instrument module and the S4B third stage booster. And that's the booster that we started out that takes us out of Earth orbit and starts us toward the moon. Some people ask, well, why is the lunar module tucked inside of that shell? Why isn't it out in the free stream like everything else where we can see it. And of course, the obvious answer is it's very delicate. Was not made to move through the air. It's made to move in a vacuum around moon. I think there's a second reason why we hid it away, and I'll tell you that. Go to the next chart. The next chart shows in the upper right hand, if you can see that, that is the limb. It looks like a piece of wadded up Reynolds wrap, and the reason we hid it in the slaw was because it's so ugly. But in contrast to that, look at the left-hand side. That's the command and service module. And isn't that a beautiful assembly? I want to point out on this picture that at the right-hand end, at the tippy top of the command module is the docking probe, and that's going to play into our discussion today. That probe reaches out and grabs the lunar module, pulls it together with the command module to achieve a hard dock, and you got to dock twice to have a successful lunar mission. Go to the next chart, please. I have to apologize to the limb guys because the limb really is beautiful. There it is when the legs are deployed. It takes shape. It has an up and a down, and it has form. And it's really kind of a beautiful machine. And it's not all that ugly after all. It carried us through 6 successful lunar landings and returned back safely. And it saved Apollo 13 and that precious crew. So we got to speak with great respect when we talk about the limb. Could I have the next chart, please? I want to talk about some of the steps leading up to docking, because docking was the big problem, the first big problem we had. As you're thrusting toward the moon with the S4B shown on the left there, you can see the SLA, or the service limb adapter, with the panels peeled back, and it reveals the limb, the lunar module inside. The command module is separated. It's in the process of turning around. We're on the way to the moon. There's no airstream. Command module has to turn around and take that probe on the front end of the command module, drive it into that black hole in the limb that you see there. And in that hole is the drogue, which receives the probe head. It's just a funnel which guides that probe head in. Could I have that next chart, please? You want to end up with a configuration like this, where the command service module is hard docked to the lunar module. That's what you go into lunar orbit with prior to descent to the moon. Go to the next chart, please. I hate this chart and I hate to show it, but bear with me a minute. It shows the 2 dockings that we must successfully carry out to have a successful lunar mission. On the left is the Earth. You launch from the Earth, you go around a couple of times, then you go into translunar injection with that S4B and that part of the stack, and that's shown as a horizontal line across the bottom there, heading toward the moon. We show 3 moons because the moon is moving around the Earth while all these things are happening. And we have to go into lunar orbit, undock, go down to the moon with just the limb, carry out lunar operations, come back up with the limb from the lunar surface, redock, and then, of course, later jettison the limb. And the S4B is long since gone. And then you come back to Earth. So I want to talk to you about the crew at this point. Go to the next chart, please. These are the guys that made it all happen. And I want to talk to you about what they got up against and how they dealt with it. Alan Shepard there at the top of the picture in the center, it was a cocky Navy pilot, very much a hot shot. He was the first man in space, as we said. He's the one that kept all the astronaut office on edge when he kept reminding them, remember guys, all this hardware that we're flying is built by the low bidder. So, but he was a very determined man. And after he did his first flight in Mercury, he was a shoo-in for a lunar landing, a lunar mission, because he was the hot shot of the astronaut corps. But at that time, he acquired a disease called the Meniere's disease, which is a disease in the ear, which made him unfit for any future flights. He was brokenhearted, very disappointed. He took a job, a desk job, as headed up the astronaut office. So his job was to choose what astronauts would go on all the later missions. And don't you know that was hard for him when he was the one that wanted to go so badly. Well, he, all through those years in the astronaut office, when he was not on flight status, he kept looking for a cure for his Meniere's disease. The NASA medic says there is no cure. You're dead. You're gone. You're no longer on flight status. But Alan was determined. He found somebody that said, yeah, I can fix that. I can do surgery. And he did it. And he amazed the medics, and he got back on flight status. And as head of the astronaut office, he assigned himself to command Apollo 14. And his dreams were fulfilled eventually. At his left is Ed Mitchell, who was lunar module pilot. He was also a Navy pilot, as was, go back, Gary, as was Alan, of course. Two Navy pilots. They were going to fly the LEM down to surface of the moon. He had a doctoral from MIT, sharp guy. The third astronaut is Stu Rusa, command module pilot. He was an Air Force pilot. He was responsible for all the docking operations. Now go to the next chart, please. I want to orient you with some of the things the crew had to do. Here's a crewman standing in the tunnel of the command module, looking up toward the LEM. And in that tunnel, he has the probe in his hands. The probe had to be installed and disinstalled, stowed, folded, put back in place, operated. It had to do many functions. It was very delicate, weighed about 70 pounds on Earth. And they had to be able to stow it, fold it up, stow it, get it back out, unfold it, and go through a number of operations. Go to the next chart.
They're laughing.
No, I'm reading an email.
This is a picture that shows the command module on the right pointing toward the LEM. The LEM is not really shown. That funnel or the drogue is shown. And you can see the probe on the command module in two positions. One is it's retracted, the one is it's extended. The extended probe has to move into this funnel shaped drogue, and the probe head has latches that capture the drogue, and then you retract the probe as it's shown in that closer position to the command module. That pulls the two vehicles together, and that causes the two ring latches to come together and to make a hard dock. So what happens here is the probe enters the drogue as the command module thrusts toward the LEM. It enters the drogue, those latches take latch, and then you retract the probe, brings the two vehicles together to the ring latch, and you're hard docked. You have to be able to clear the tunnel. There's a command module hatch you take out, stow. The probe you take out, fold and stow. The drogue you take out, stow. And the LEM hatch you take out and stow. So a lot goes on there. Well, what went wrong with this whole thing? On Apollo 14, the probe head was driven into the drogue like it should have been. The capture latches did not capture. Big problem. You can't dock with that kind of a condition. So what are we going to do about it? Well, there were a number of tries made, and we were eventually able to do it on the 6th try. Here's how it was done. First of all, Stu on the first try, he drove the probe into the drogue, did not capture the vehicles, bounced back apart. He tried it again, same thing happened, vehicles bounced apart. On the third try, he says, I'm going to drive it in harder. I'm going to make sure that that thing really gets in there and has time to latch. Did not work. fourth try, the mission control was suggesting a dozen things, and one of them was to recycle all the circuit breakers that are close by, and they did, and that didn't work. They made a fifth try, and that did not work. All the hand wringing that was going on the ground. To go to the next chart. In the mission support room, you can see a probe was sitting on the floor, and looking head on at us is Gil Ruth, who was the mission director, center director at MSC. Next to him was George Abbey, the famous astronaut maker. On the right-hand side of that was John Young, who was going to command Apollo 16, and they're all trying desperately, along with us and Downey and all of mission support, trying to figure out what to do. We have to recover this mission. Well, a very bizarre technique came out of that. What we did, we drove the probe head into the drogue with the probe extended. We kept thrusting to keep it in there, keep it pushed in. And although the capture latches did not latch, we retracted the probe in that condition, which provided guidance for the two vehicles so that they could come together. And by keeping on thrusting, we pushed the two vehicles together. The ring latches made, and we were hard docked. It was a very bold and daring thing that was tried there. It was maybe an act of desperation, but somehow it made sense at the time. And looking back on it, I don't know, but it worked. So go to the words on the left-hand side of the page. Here we were able to work around a problem. We knew that probe was a critical system, but it had passed all the qual testing, environmental, the air bearing, structural, all kinds of testing it passed.
Okay.
Difficult
I
system.
didn't know I was using.
We were able to work through all that. It was used on
Thank you.
five prior missions, which involved 9 successful dockings. And we fully had expectations it would work on this mission. It did not. Took 6 tries. Finally, a brute force solution that was pretty hairy, but it worked in orbit. We brought the thing home, inspected it, tested it, found no problem, worked like a champ in the lab. Never really knew what the problem was. I think it was a lack of robustness. The system was just too delicate. You just don't want to send stuff like that out into space. Maybe a little burr on a piece of metal, maybe a little contamination. It didn't work, and then we brought it home and it worked fine. In fact, it worked on the second docking. And let's talk for a moment about the thinking that went on at this point. We were able to brute force dock for the first docking. We were on the way to the moon. We were going into lunar orbit. All this time we're worrying, well, dare we separate the limb from the command module and go down and do the lunar operations? Because when you come back up, you have to dock. We got a probe here that won't dock. So what are we going to do? Well, we had a workaround. It was an EVA where the limb would come back up from the moon. It would station keep with the command module. The guys would climb out of the limb and crawl into the command module in pressurized suits. That had never been tried, and nobody ever hoped that we would ever have to try it, but that was the backup. We went ahead with the second, with the lunar landing, and with the second docking, it worked fine. So all is well, right? Go to the next chart, please. However, this crew's problems were not even beginning to end. When the crew, Alan Shepard and Mitchell, crawled into the limb, undocked from the command module, they were station keeping with the command module. They were 200 or 300 yards away. They were going through the checklist to be sure they're ready for the descent to the moon's surface. They were very startled when they got an abort light, abort warning light in the limb, which meant that if they armed the descent engine, the limb would automatically abort the mission and thrust the limb back toward the command module. That means all the game was over theoretically, because they could not go down to the moon surface in that configuration. More hand wringing, more troubleshooting. The crew found that they could tap on that switch and they could get an intermittent, which probably meant a solder ball was in there. They dare not throw that switch. So by this time, Mission Control had activated Draper, who cut all the software in the limb. Draper's part of MIT up there, and sharp bunch of guys. There was a young man named Don Isles. He was a nerdy looking guy, looked like a hippie. You wouldn't choose him to save your program, but he knew that software, and he knew he could sit down and he could write a few lines of code that would trick his software into ignoring that switch. And it worked and cleared the problem. You know, there's another story that they used to tell about that last step. The original story was that Don Owls was home in bed asleep. They sent a car out and got him in real time, brought him in his PJs and robe, sat him down, and he wrote the code and sent it up. I saw Don Isles in an interview more recently. Don said, you know, that's a great story, but it's not true. I was in the building. I was not in mission support. But anyhow, Don Isles saved the mission at that point. He was highly decorated later, and he certainly deserved it. So now we're thinking about, let's go down to the moon. We're home free, not to be. As they got down closer to the moon, they're committed. They're either going to land on the moon or they're going to abort. Well, you know, Alan Shepard's not going to abort because he's waited half his lifetime to make a lunar landing. So on the way down to the moon, there's an event that must occur, and that is the landing radar from the limb must acquire the moon. And it happens at a point somewhere on the way down. And this event did not occur. The landing radar would not acquire the moon surface. So they know they have to have this. All they do have is the inertial data in the computer that tells them how high above the moon they are, and that's not good enough for a lunar landing. Well, it was a very desperate time, and this story is told that Alan Shepard looks over at Ed Mitchell and he says, as they're going down and they don't have the landing radar data, Shepard said, Ed, we're both carrier pilots. We can land this thing. And of course, he was counting on his inertial data and his visual out the window. Well, you're not supposed to do that, but they said, we're going to do it. All this time, mission support, of course, is working the problem. And it turns out they recycle circuit breakers. And for that or some other reason, the landing radar did acquire, and they got the data they needed. So now they're home free. They're going to go down. They're going to make a successful landing and carry out what they set out to do. And they spent 33 and a half hours on the moon as planned. They brought back 94 pounds of rock. The startling thing about their duty on the moon was Shepard walked over 9,000 feet in a pressurized suit. Can you believe doing that? Well, the liftoff from the moon was precisely on schedule. They had a very successful mission. I think it was successful because they had great procedures, they had great support, they had great training, they had high determination. The crew was determined to carry out that mission no matter what. And that crew was very skilled. They overcame these three major problems. And to me, that is the legacy of Apollo 14. go one more chart and I'm all done. This shows a happy ending. And I'm sorry, one more chart. Happy ending, we trained our parachutes to take a bow for the cameras at the end of a successful mission. And that was a good way to end that whole beautiful experience. I want to add one more thing. I'm through, but San Diego Air and Space Museum is having a 2-day Apollo 14 memory video program where they're going to have Jerry Griffin, who's mission controller, and Fred Hayes, who flew on Apollo 13 and was Capcom on Apollo 14. And they're going to put on a 2-day program, not all that many hours, but 4 o'clock on this Friday. Tune in to San Diego Air and Space Museum. And there'll be the first part of that. And then on Monday, there'll be another session on the February the 15th. I'm all done, Gary.
Hey, that was a wonderful presentation. A lot of filler information in it. I'm going to go back a couple of steps here too, because I picked up a couple of things in the course of prepping for this. The comment you made about Isley doing the programming. Yeah, the gimmick that he used on that was actually to tell the abort system that it had already functioned and that the abort engine was already firing. So that meant that it couldn't reinitiate. And a background of that was that, is everybody getting echo?
Yes,
Sorry about that. I don't
you
know
probably
why.
need to turn off one of the microphone.
Yeah, I turned off one already, but there we go. There we go. I hope that did it. Nope. Still no luck?
Yeah, it's still, it's
Oh,
better now. It's better.
okay, then I'll keep on hitting that minus button and see, hope that it gets down. Looks like it's getting there. Okay, so anyway, when we had
Oh, it's coming back.
yeah.
Yeah, I think one of the microphone also need to be kind of.
Yeah, I don't want to do the other one. Well, I thought I did it. I don't even know where the mics are on these things. So
Yeah, normally I turn off one of them, you know, the microphone and the speaker.
oh, that's what I did that.
Now we need to unmute this one. Can you unmute this one? Is it on Zoom, the lower left corner?
Sure.
Okay.
I think it worked.
Yeah.
Looks like it worked. All right. Well, anyway, when we had Van Allen, Jim Van, what's Van Allen's first name? Anyway, Richard Van Allen.
Rich, yeah.
Rich Van Allen was a former chair of the local AIAA section, and he also, as a graduate student, spent a summer in 2009 in the astronaut training office, or the astronaut mobility office in Houston. And he had a story about the lunar module descent engine. And during the initial testing of the LEMD, they found that when they ignited the descent engine, the radar, the terrain acquisition radar on the lunar module thought that the rocket plume was the surface, and it wanted to shut off the engine. So when they were doing that, that wasn't him. Who was that? Anyway, oh no, that was John Stamrick. John Stamrick was telling the story. John had worked in the lunar module in the lunar module at Grumman, and he did such a good job of monitoring TRW on their lunar module descent engine contract that the management at TRW decided to hire him out here and put him in charge out here on and working on some of the lunar module engine out here. So anyway, when John was in Grumman, they discovered this problem, and they suggested that maybe the answer is to find a way for the astronauts to turn that abort system off. And indeed, that's what they did. John spent a good day digging around in the schematics and the wiring of the lunar modules, and he found the power wire that would operate the that would allow the computer to operate the ascent engine to initiate the abort sequence. And so they put a switch in there that the astronauts called was something like the option switch. Anyway, every landing was made with that switch flipped over. And so the fact that they had difficulty getting the descent radar to come live on this mission brought up another part of the story that we've seen in one of the previous Apollo 50th anniversary commemorations. So we've got an amazing group of people here that worked on this program some 50 to 60 years ago. I go back almost 55 years right now. Okay, so that was one of the stories. And the other thing was that the chart showing well, I'll bring it up in a minute. But the chart, there's a chart from NASA that showed the sequence of those 6 attempts to dock in orbit on that, or in the translunar flight. Now, what Chuck did not say about that was that they had already fired the S4B on that mission, and so the entire stack was going to the moon. And if they had been unsuccessful in docking with the LEM, they would still have been going to the moon. I don't know what options were being discussed about that at the time, but as he noted, that was a single point of failure, and it's a very critical part of the mission. So anyway, I'll I'll try to fill in more here, but anyway, does anybody else have anything they want to contribute? Anybody who wants to contribute, please unmute. And speak up.
I have a question. Can somebody talk about the golf ball, Alan Shepard?
Oh, yeah.
Yeah, brought up there. It's kind of fun. And Chuck, do you have the picture of the hippie gentleman who fixed the computer code that you mentioned?
Do I have a picture of him? No. Well,
No.
I've seen pictures of him, but I don't have one with me. No.
I did find that picture today. Unfortunately, I did not download it, so I don't have it.
The golf ball? The golf?
No, that's a different story.
Oh.
Well, Alan Shepard, like I said, he was a cocky young guy, and he thought he would make a big splash in the news if he knocked a golf ball. And it's kind of hard to do with a spacesuit on, pressurized. And his first attempt, by using one of his tools that he carried along, an official NASA tool, it didn't work, but he was able to get a hit on the second try. He held the club with one hand and swung it, and he did hit the golf ball. And for all these years, I think people are still trying to calculate how far the golf ball went, but it certainly set a record.
Uh-huh. Yeah, here is the what's the matter with this? So that wants to go full screen. And that window is off in the presentation. Oh, I did it last time. What's going on here? Ah, come on. Slideshow. Where's my slideshow button?
Yeah, Chuck, I just saw some news. They said they found that golf ball, but it's only 40 yards. So they didn't try to make it very public, but they found it.
Maybe that was the first one. I don't know. He carried two of them.
Oh, two. Okay.
Uh-huh. I think he reported that one of them went over the horizon on the moon when he hit it.
Uh-huh. Where's my full screen display here?
You need to use share screen again.
Oh, there we go. It was hidden. There. Oh, I have to hit that again? Of course. I do? No, it's there. Okay, so here's the sequence of those probe capture attempts. And yeah, they're both showing that. Whoops. This computer does not like to be moved fast. Okay, so yeah, so the first try, well, they call them 1A, 1B, 1C, 1D, 2, 3, 4, 5, 6. So the first one, no thruster activity, close to the apex. Second one was all the rest of them were close to the apex, and then they drive in. And the final one there, they did a contact moderately close to the apex. They initiated the retract cycle almost 7 seconds after contact, and the initial latch to the ring did it another 5 seconds later. in my experience, one of the tasks that I did was to do some work on those latches. And when we initially did the first qualification test on those things, the latches themselves, which were kind of like a shape 7. I'm going to put the view back on. The latch kind of sat like this, and when it triggered, it clamped down very powerfully with powered by a stack of what we call disc springs or Belleville springs. And of course, the clamp had to be strong enough to pull down against against some atmospheric pressure. And so they were very powerful springs. And we had an issue when that first 17.4 pH precipitation hardening steel latch went up and clamped. More than one of them failed in the shock of that clamping. They were high strength, very high strength heat treat and quite brittle. And that was the first instance where I ever was involved in using Inconel 718, which is a more ductile, primarily nickel alloy. And that solved the problem. So those latches were one of the things I worked on. And another part of the story about the latches and about the probe, I don't know if anybody recalls the story about the Apollo 13 movie, in which Schweigert talked about, was at a party and he was giving a description of the operation of the probe and drogue, and he invited the young female he was with, the bachelor. Schweigert says, "So you hold the glass, and you can be the probe, or you can be the drogue, and I've got the probe over here." And he gave a very graphic description of the mating of the command module with the lunar module, with heavy inference of his real intentions there. And anyway, it turns out that what we did in the qualification of the probe was we put the drogue on one sled and a probe and a mass on the other sled on an air bearing table. And then we floated these two sleds as they came together, and watching that gave me very graphic dreams for a few days. there were, but of course, the one thing about that was that the installation on the flat surface forced the probe and the drogue to have zero rotation relative to each other. And that was always one of the concerns about why mating in space may be a difficult matter. So they basically have two dynamic bodies, and how do you maintain those precisely enough that you can get these tiny little latches to come over this sharp edge and make a good grip. So there's a couple of my stories. Anybody else have one? Chuck, I'm sure you saw some of that testing on the air bearing table.
It's been a long time.
I'm sure.
Yeah, I remember when they shined up the floor and got the sleds ready and we carried out. We also had another program with like a three-dimensional simulator. I forgot what it was called. It was at Houston, and put the probe and the drogue through a lot of extensive testing. Well, it was just a delicate system. Once George Lowe took a look at it early in the program, he said, that is a magnificent machine. He says, it's built like a Swiss watch, but it can stop a freight train. My reaction to that was, well, Swiss watches are nice, but I don't want to send one to the moon. I want it to be robust. I want to send the freight train to the moon, not a Swiss watch.
Freight train latch, yes. Huh. Okay, so somebody's sending us a text.
Oh, I was just asking Harvey because his camera is blank, so maybe he's need to restart the camera or something.
Oh, this is Harvey who?
Don't know his last name, but I suspect it's the Harvey we know. But I don't want to make a presumption.
Yeah, there's two Harveys that I could think of, and one is Don Harvey, who was kind of the chief engineer on the lunar module descent engine, or one of them, and the other, the Harvey at North American, I don't have the last name of him, his last name.
Harvey Hartzell?
Don't know.
Maybe you can ask him to speak up.
Is he still on board?
Yeah, he is, but muted.
Okay.
Okay, he's.
Okay.
Harvey, can you
sort of
say
ran
something?
out of things
Can you
on
hear me
my
now?
Share screen.
Yeah, I can hear you.
Okay.
We can hear you.
I'm going to leave my share screen on there, but you can go away from having the, you can go back to the gallery view so we can all see each other there, Ken.
Okay, we'll do that.
If somebody wants to refer to anything in the presentations, we can bring that back alive.
Yeah, Harvey is on, so if you want him to share something, and the self introduction in the beginning, we didn't complete. Yeah.
Yes, please.
Harvey, do you want to say something?
No, I don't have anything to say right at the moment.
You tell us why you're here.
I'm late logging in here. I was out somewhere this morning, so.
Okay.
But in the future, I'd like to be more involved here.
Well,
Remember, I used to meet you over at the museum.
Oh, okay. Yeah, okay. That's the other Harvey I was thinking
That's
of.
the other. Yeah, that's the other Harvey.
I don't know how to get my face up there, however.
Is your camera on?
Yeah, his camera is on.
Okay. So where is he?
I don't know. It's his camera, either something in front of his camera, or somehow it was not starting properly. Actually,
now
initially,
there is a shutter on most cameras. So if you go up and feel the top of the screen where the camera is, you might be able to slide it probably to the right to see if there's a shutter on your camera. That's a good idea to have on, by the way, because some of these programs, Zoom, for instance, don't really invite you to shut down, and you can very often find yourself coming back live on the system. You have no idea how long that camera has been operational, and So
I'll have to figure this out.
Hey, Gary, this is Chuck. I've got to leave. Thanks, Ken.
Oh, okay.
Thanks, Gary, for putting this on. Been fun. Good seeing
Okay, thank you
everybody
very
without-
much for,
Good seeing everybody without a mask.
I especially loved your presentation with the introduction to Shepherd and the other crew, all the other details you put in. That's one of those guys who's been there and done that. Thank you.
Thanks, Gary.
All right. So who is left? There's Ed Smith. Ed, did you introduce yourself at the beginning of this show? Or was that the very, very beginning?
I did.
Yeah.
I'll make a few comments.
Yeah.
This is very interesting. I've listened to Chuck give this little spiel about 4 or 5 times, and each time I get really jazzed up. And I think most of us that live this program remember the days when, and it didn't just stop with this program. It fed over into the shuttle program also. But basically, we went at this like this for every day. It was like a new problem, which we worked very hard. I think Glenn Lundy made the comment in one time in one of the presentations on Apollo 13, where at Apollo 13 we really solved a lot of problems like this, only in greater magnitude. But it was a big team effort. The guys in this room that you see here are just a small sampling of the many, many people that were involved in each one of these flights, and even during the build even, and constantly we were dealing with problems of this order, where we went full out to understand the problem, solve it in a timely manner, and with the minimum impact of the program. But you think about a flight program like this, where we had an active flight directorate, which people argued many times about whether or not we should need a flight directorate. Why didn't the pilots fly the damn thing? I think this is a good example. Another aspect of it was we had a backup room with a lot of our experts and the LEM experts and the NASA experts in Houston backing up the flight directorate. And we, both Drummond and ourselves, I had a full engineering department that was standing by to work every problem that came up. And although this might be one problem that's very interesting, there's 1,000 of them. I sit down, in fact, I'm writing my daughter has me writing for Storybook, if you know who that is, kind of a manual of my life. And I sit back and think about all of the stories I could tell in detail, like this one, that all these guys worked hard. We worked hours, untold hours. I can tell you a million stories like this that are just as fascinating, where we solve problems in real time. And as I tried to point out earlier, Glenn Lundy made the comment after the Apollo 13 flight, that we learned during that flight more than any other to work this team. And immediately, it wasn't just a little team, it was a huge team, thousands of people. We work them full bore and in a synchronized way that yielded a positive result. And I can't ever emphasize that story. It's unfortunately impossible to tell, but some days I have sat down many times and listed all the problems I think that we worked that way, and as a team, and brought it to a successful conclusion, not only in real time of flight, but during the build, etc. It's a fantastic story. It's in this program that probably never shows up I remember when I went back to the Air Force programs on B2, and you know, the Air Force, we just weren't really used to working that way. And I had a hell of a time keeping that what I call stimuli working, and which I thought was a real stimuli for young engineers. You learned so much so fast, and you had to really think and do well. I go on. I got rattled on this way forever. Sorry about that.
Hey, that was good rattling on. And you know, there were so many of us that were the 22-year-old new hires on the program. And we really needed a contingent of the experienced people to support that. I came in as a 22-year-old fresh graduate. And yeah, one of the things that was really, people have said so many times, is that everybody on the team really had the feeling of being on a team. And the stories were that even the janitor, when you asked him what they were there for, what their job was, they could say that they could quote Kennedy's admonition at the initial goal or mission statement of the Apollo, to send a man to the moon and return him safely by the end of the decade. And it's amazing that with the huge interruptions that we had, especially after the pad fire, that we still made that deadline. So, but unfortunately, somehow the news media or the population made it a simple, presumably success. You know, the success just really defeated the excitement and the interest in the program. So it's great that we still have some people interested in the advancement of space flight, and it's great to have the old veterans that are still here to talk about what we did. And with regards to the number of failures, one of the things that I repeatedly tell people is, you know, we were supposed to work to a reliability level of 5 nines 5, meaning 5 failures in a million. Trouble is, we had 6 million parts on the spacecraft. You could expect at least 30 failures per mission, and I think we satisfied that estimate. Anybody else out there? Well,
yes, this is Van out there. Is Chuck still there?
No, he had to check out.
Oh, I was just wondering about when he talked about the Air and Space Museum in San Diego. He didn't really give the times that the people were going to be there, but I guess I can go onto the Air and Space Museum and find out all about this Friday and next Monday's show. Because on Monday they have a holiday with the I think it's the Washington's birthdays, so that's going to be pretty crowded. Okay, thank you. Yeah, good presentation. What?
Yeah, hold on.
Yep.
Yep, I got a phone call. I have to go.
Okay. Well, thanks.
Yeah.
Thanks, man.
I'm gonna have to go. This is Janet. My dad was Dale Myers.
Oh, yes.
He would have loved you guys getting together and talking this way about what an amazing thing happened all those 50 years ago. And thank you for being here and doing this thing.
Okay.
Thank you.
Yeah, you sent an email requesting that, suggesting that you like the idea of the landing date,
Oh, yeah, the
February
5th
5th.
of my mom's birthday. Yeah, they're both in heaven. So, yeah, thanks a lot.
Okay. So who else do we have here? Hey, Harvey, what did you do on the program?
I was involved with the lunar module.
Right.
The design and then supported some of the missions.
Uh-huh.
And then I moved over to the space shuttle.
And you also have done some things with the Columbia Space Center, Columbia Memorial Center in Downey, amongst our 50th anniversary events.
No, but I attended that meeting we had up in Santa Monica on the 50th.
Oh, okay. Well, well, Jerry Lockenhauer is here. Unfortunately, the Apollo predates you, I think. But how's the weather in Pennsylvania today?
I got to watch and cheer on, and I think I was a couple of years out of school when that happened. So the first landing, anyway.
Uh-huh. Cool.
So I do have a question. You know, as Chuck mentioned, this is the first very important or successful return to space to the moon after the success of Apollo 13. But how do you feel at that time? Do you feel think that the Apollo program will continue? Would you expect that you will actually stop at 17? So what was your mood at that time? Would you feel so excited you will establish some permanent, base on the moon? How do you feel at that time?
I was off the program in 2 years. So by 68, before the first Apollo 7 launched, I was off working on other projects. So I don't have that information. Jim Rowe stayed on for a long time. So did Ed Smith. You guys pipe in and make something, or?
I think
Bruce?
I'll give it a try.
Sure.
I think the question was, what was our attitude relative to the continuation of the program? Positive attitude?
The time with the success of Apollo 14.
Well, again, I say we worked so hard on every one of these problems that there wasn't any doubt in my mind. As a team, we felt we knew how to take care of anything that had come up. And Apollo 13 was really an eye opener to a lot of us in the sense of more specifically our ability to work as a solid team. And I think going into 14, we'd worked very hard to make sure that the things that happened in 14 were going to recur. And of course they didn't, but we always have the new ones. And I can only say that we were very positive about our ability to make it happen. I had no doubt in my mind that our ability to continue the program was a positive one.
Mm-hmm. So did Jim? No, Jim's still here. Jim, do you stay on throughout, or I think you were at North American for the North American Rockwell International / Boeing. So so do you have any comment about that? We got to unmute you. I might be able to do that. Well, I guess I don't have control on that.
Yeah, you can ask him to mute, but it's their choice.
Yeah, right. Okay, well, we've stretched this for over an hour and a half. Sorry for the for the fumbling opening of the whole show, but we got there. Oh, there's his tech support coming in.
Yes, indeed. So now you're unmuted, Dad.
Huh?
Now you can talk. Now you're unmuted.
Oh, yeah, this is Jim Rowe here. I started in '61 with the Apollo and worked all the way through until, I think in the '70s, well into the '70s.
Yeah, and at the very end of the Apollo program, of course, the shuttle program initiated, and you carried on with that for that. Well, I think maybe it's time to bring this thing out, wrap it up. If anybody has anything, oh, hey, come on, Sergio. Or you're waving at us. Farewell.
Yeah, I was going to say that I really enjoyed the get-together, and like Chuck said, we sure missed the get-togethers at the not the soup plantation. What's the name of that place?
The hometown buffet.
Yeah, right. Yeah, I can't add anything to Apollo. I didn't work Apollo, but it sure was one of the programs and activity that motivated me to study aerospace engineering. And fortunately, I was able to start with the shuttle after school in 1973. And that's where I met Mr. Jim Rowe, and I worked under the leadership of Ed Smith. He probably doesn't remember me, but I'm sure he remembers Fred Lespesa and Don Schlosser, True Serber, and Bert Whitty and Bill Borneman. Those were some of my managers.
I do indeed. And you.
I hope we'll be able to get back together again for our Christmas luncheons. Who has had the vaccine, if I can ask?
You have it.
This is Harvey. I've had the first shot. I had it on Saturday.
He wants to know who's had the vaccine. You have.
Number one.
Yeah, I had my first one. I had my Pfizer first shot Sunday, and I'm scheduled for the 26th of February for the second one.
Okay.
Second one on Sunday.
Great.
Yeah, I'm due for the second one on Sunday, this Sunday.
Okay, great. Jerry, did you get in the line yet, or?
Yes, I've had my first shot a couple weeks ago and get the second one on the 27th of this month. So
Sounds like the Moderna?
yes.
Yeah, I had the Pfizer and I've had my second, so it's and now they're taking the joy and the relief of certainty of being able to go back to normal away with all the variants that they're threatening us with right now. So this is likely to be a long-term problem. Hopefully much less severe than what it's been so far.
Yeah.
Okay, well, Ken, do you want to escort us out, or?
Oh, okay.
The individuals, we haven't stepped up to the plate and done our own thing. So goodbye, guys, and it's great to see everybody.
Okay.
Look forward to.
Thank you, Ken. Gary.
Thank you, Ed. Thank you.
We will be
Yep.
having an Aero alumni meeting next Wednesday. Not tomorrow, but a week from now. So keep your eye out in the mail for that, and we'll see you again soon.
Okay,
Thank you, thank
Have a
you.
good one.
Yep. Thank you a lot.
Thank you.
bye-bye.
Okay, I'm gonna sign you out.
Okay. I wonder, do I have to, Ken, do I have to do anything clever to stop the share? Yes, I do.
Oh, no, you can just the end of the meeting. Yeah.
There, I hit the stop the share. And so now we're looking at,
Look, lower right, you should see a red button called
Yeah.
end.
yeah, I know how to bail out. I'm just
Oh.
looking at the screens
Oh,
and I displaced from one view to another. So,
yeah, it had many, yeah, we have many screens. Yeah.
okay. Well, thank you so much.
Oh, no
And,
problem. Anytime, anytime.
Hey, go ahead and send me the link for the
Next week, right?
next week.
Yeah, sure. I will do that shortly. Yes.
And we probably should talk on the sideline sometime about the council and what's going on. So
Exactly, exactly. Yeah.
your haircut's getting to be like mine.
Yeah, we have to get her car. They all shut down, closed.
I'm approaching a page boy haircut myself.
Yeah, me too. It's you know, maybe you should try it. Now you have two computers. Maybe you can one look at it next to each other, and but be careful, don't cut your ears. Maybe better safe to wait a little bit. Yeah.
I think I'll wait for somebody else to do it.
Yeah. Maybe we can make it longer and put the strap like a hippie. You know, like a hippie.
Go to a man bun.
Yeah. Yeah. Also, the tennis player. You know, they all have this thing that I think remember this. There's Edberg. You know, Edberg, this tennis player. Steve Edberg and Borg. This from the Sweden. I think Borg. You know, they all have something like that. And that, you know,
Back a while. Yeah.
yeah. McEnroe didn't have that. John McEnroe, he did.
He was always pretty short cut, I think.
Yeah, he's always pretty shortcut. But there's a Borg and I think the other player, they always have some kind of fancy things.
Yeah. Okay, well, I'm going to leave this one.
Okay.
And then
Now you see.
That's a good move. And
Good.
now I'm down to just the one.
That's right.
Okay. Well, thank you again.
Oh, no problem. Anytime. Stay in
Great.
touch.
Have a good day.
You too. You too.
Yeah. Bye.
All right.